theme of today's session, this session is Achieving Resilience through Advances in Biomedical and Telecommunication Engineering. This session will be chaired by Dr. Tharaka Mohotty and the rapporteur will be Engineer Samarawickrama. Yes, sir, I would like to kindly invite you onto the head table here. Thank you very much, sir. Now, I would like to invite all the authors who are presenting in today's session onto the head table as well. Thank you very much, everyone. So before starting the session, let me give you a brief introduction about our session chair, Dr. Tharaka Mohotty. Dr. Tharaka Mohotty is a television broadcasting veteran with 36 years of experience, excelling in many roles in various domains. He currently serves as the Chief Executive Officer at EAP Broadcasting Company and also holds the post of Chairman at the Institution of Engineering and Technology, Sri Lanka Network. Dr. Tharaka's academic journey led to a PhD in Business Administration and Management from the University of Acoustic, Philippines, complemented by a Master's in Business Management, a Master's in Labor Relations and Human Resource Management, a postgraduate diploma in Electronics and Communication Engineering from the University of Moratuwa, and a postgraduate diploma in Labor Studies from the University of Colombo. He is a distinguished international professor, a chartered engineer, and a fellow of the Institution of Engineering and Technology, UK. Dr. Tharaka is also a decorated industry leader, having received prestigious awards in recognition of his exceptional contributions to broadcasting engineering. He is a proud recipient of the Developing Broadcasters Excellence Award and Broadcast Engineering Excellence Award at the Asia Pacific Broadcast Union in 2013 and 2016 respectively. Dr. Tharaka's illustrious career includes significant leadership roles such as the former Director of Station and Director of Engineering of NTT as well as the former Director of Engineering at Sri Lanka Rupawahini Corporation. His influence also extends to the international stage, where he served as the former Vice Chairman of Asia Broadcasting Union. He also lent his expertise as a short-term consultant to the International Telecommunication Union, contributing to global telecommunication initiatives. Furthermore, he has also played a pivotal role as the curriculum advisor at NITA, shaping the educational landscape in his field. So, without further ado, I would like to hand over the session now to you, sir. Thank you.
Thank you. Good morning, everyone. And I welcome all the authors and co-authors. And for this session, there will be 5 papers, and each paper will get 12 minutes of presentation time. At the 10th minute, there will be a buzzer for allowing for about the next 2 minutes to have wind up. And there will be 3 to 5 minutes of question and answers. Further taking too much of time, I would like to invite for the first presentation. The first presentation is on Internet of Things, Intravenous back monitoring and alert systems. This particular presentation will be delivered to you by Ms. BHMD Wijesinghe. Ms. Wijesinghe is a third-year undergraduate who is following BSc in Electronic and Telecommunication Engineering, General Sir Chairperson. Her primary research focus centers on the field of Internet of Things and its related domains. She is passionate about exploring various facets of IoT technology in the future. So it's
Thank you for the introduction, sir. Good morning, ladies and gentlemen. My research topic is IoT IV bag monitoring and alert system. This paper is co-authored by Sir Captain DDGR Karunaratne, lecturer at the Department of Electrical, Electronic and Telecommunications Engineering of KDU. So, to start off, if I talk about IV therapy or intravenous fluid injections, it is an important medical technique used in hospitals to deliver saline, blood and other nutrients to patients' veins. This process should be monitored properly and carefully to remove the IV bag or replace it on time in order to prevent fluid backflow or blood loss that could affect the patient's health. Doctors and nurses may occasionally be too busy to supervise every patient individually while attending to other important tasks as well. Especially in developing countries where the number of patients in a hospital is higher than the number of medical staff, and also in critical situations like the COVID-19 pandemic. The existing products in the market involves the normal IV drip, mostly used in local public hospitals and medical centers. This does not have a remote monitoring or alert system. Next, the pump infusion method, where the fluid movement is controlled by a pump, and various kinds of smart pumps are also used to deliver fluids and drugs with a predetermined criteria to patients, but they also have to be monitored from time to time by physically attending to them to ensure proper delivery of fluids without any technical issue. They also do not have a remote monitoring or alert system, and they are very expensive as well. Therefore, as a solution to this problem, an IoT-based IV bag monitoring and alert system can be implemented. It monitors the level of fluid in the IV bag, displays the level of fluid on a screen and on the mobile phone so that the nurse can monitor while attending to other work, sends alert notifications to the nurse so that the IV bag can be replaced or removed on time. Moving on to the methodology, the prototype is programmed in such a way that when the circuit is switched on, it would establish a connection with the Wi-Fi network. Once the Wi-Fi connection is established, the IV bag can be hung on the 1 kilogram load cell, which measures the weight of the IV bag. The 1 kilogram load cell used is calibrated before use so that it measures the weight accurately. The calibration factor is calculated by taking the ratio between the weight shown by the prototype and a known weight. This value is included in the Arduino code so that the accurate measurement of the weight can be obtained. So this prototype is made for saline, and since the density of saline is approximately equal to the density of water, the weight shown on the LCD display or the phone in grams is approximately equal to the volume of the liquid remaining in the IV bag. Since a standardized IV bag has a volume of 500 milliliters when it's full, as the fluid is delivered to the patient, the weight gradually decreases, and when the weight is equal to 250 grams, an alert notification is sent to the nurse's phone through the Blink app, indicating that half of the fluid is delivered. so that the nurse can remove or replace the bag as required. Moving on to the components, a manual switch is used to turn on the system. The prototype uses two 3.7 volt batteries to power the Arduino Uno as well as the other components. A 1 kilogram load cell is used to get the weight of the IV bag as I mentioned before. And the HX711 module is used to connect the load cell to the Arduino Uno, and it offers amplification and analog to digital conversion functions as well. The Wi-Fi connection is obtained by the use of ESP01 Wi-Fi module with the adapter, and all the processing of the data from the other components is done by the Arduino microcontroller, and the output of the weight is shown on the LCD display as well as on the mobile phone. The prototype was implemented successfully and the system was analyzed to obtain the following results. At a rate of 250 grams, the volume obtained was 270 milliliters, and at a weight of 125 grams, the volume shown was 135 milliliters. As you can see, a small variation in the values obtained is because as the fluid level in the bag decreases, the bag shrinks and it weighs less because the material of the bag is folding or compressing, affecting how the weight is distributed and measured by the load cell. So since the values do not differ significantly, an assumption was taken that at a weight of 250 grams, half of the IV is delivered, and at a weight of 125 grams, the IV level is low. The notifications in the Blink app can be set to these values, so the results shown were obtained. This is the notification when half of the IV is left, and this is when the IV level is low. These thresholds can be changed and set according to our requirement. This is the final prototype that was developed. The 1 kilogram load cell is attached to the hook shown on the image, and the IV bag is hung on it as shown. So, as for the future improvements, this system can be modified to deliver different fluids with different densities by doing an analysis of the weight obtained for the specific volumes and thereby setting necessary thresholds as required. Also, this prototype is only for one patient, so in the future a database could be created and data of all the patients in a hospital can be stored and displayed on one screen in a common place where the medical staff can easily observe. To conclude my presentation, as the time-to-time monitoring of IV fluid delivery process is a difficult task for the medical staff, an automatic IoT-based IV bag remote monitoring and alert system was implemented. So the weight of the IV bag is sensed and displayed on the mobile phone as well as the LCD display, and the system can be set to receive alert notifications at required thresholds. Overall, this design is very beneficial in safeguarding patients' health and also reduces stress and workload of the medical staff. These are the references that I used for my presentation. So, I would like to thank all the lecturers of the Department of Electrical, Electronic and Telecommunication Engineering of KDU for their valuable feedback and guidance, and co-author Sir Captain DDGR Karunaratne for the support extended. Thank you.
How long does an IV bag typically takes to deliver full content?
Like 15 to 30 minutes.
Blood derivatives? Can those be hung in a bag like that? Or are there special ways of doing it? Because when you are making a general comment, you must check and see whether it can actually be done. Did you check that?
No, sir.
So, in a project it's very important to look at the practical considerations and see the applicability of it.
I also have the same question by because why did you select those threshold values of 50 times and 125? And the second question I had was like now, according to your model, you have to place those devices to monitor the levels in each and every bed. So how practical it is in real application, implementation?
Yes, sir. So for the further development, I have to visit an hospital and in the actual implementation, I have to take the feedback of the person who is actually using this medical stuff. So it should be addressed in the future.
The work is really good, but I have one problem. Why you directly move into IoT-based application other than just have an alarm or like a simple thing? Why? What's more motivation you have to go to this IoT? Is there any reason?
Yes, sir. So I am planning on checking and doing the analysis on IoT-based systems. So that's why I had the motivation to implement an IoT system for this project.
Sometimes maybe with a simple application, same thing can be done. That can also be done. You can check all those possibilities also. I would like to make a comment. Many students want to go for IoT or something similar, which they can do it with much easier things. Because they are doing electronics, maybe that is the option you want to do, because then you can show to your supervisors and others that you have implemented electronics part. But then the important part is not the electronics, the delivery of the fluid. So there is something you must think about when you are doing project something.
I also have a small question regarding your setup. You showed that your measuring setup is on top of the fluid bag and it's hanging on a hook. So normally you will, in real world, you will have the wind and other small fluctuations. Sometimes someone might, when the patient moves, there are small so it can move here and there. So can you explain about the error calculations of those scenarios?
So the 1 kilogram load cell used should be a very high quality one. If it is a high quality one, these limitations due to pressure and the wind can be minimized a lot.
How about wind and all that? Those little fluctuations, will that affect the reading, or have you thought about it?
I don't think that it will affect the reading a lot.
We can have one more question. Okay, thank you, Ms. Wijesinghe, for your presentation, and I hope the questions posed by the panel and the audience will give you a more proper development of the system. for your presentation once again. Thank you.
Thank you, sir.
The next presentation is on advancements in Manikin technology, enhancing realism and effectiveness in nursing education. The presentation is authored by Abeysuriya, KD Samarawickrama, WLPK Wijesinghe, IMCWB Kohombakadawala, SAC Dalpatadu, JRS Silva, and EHADK Hewadikaram. This paper will be presented by Mr. Abeysuriya. Mr. Abeysuriya is graduated from Kohombakadwala Defense Academy, Defense University in Biomedical Engineering, and currently a postgraduate student following MSc Biomedical Engineering at Kohombakadwala Defense University. He worked as a research assistant for the project converting low fidelity mannequins used in medical education to high fidelity mannequins. So over to you, Mr. Yuvesh.
Good morning, everyone. Thank you for your introduction, sir. So, my article is about, it's a review article, it's about advancement in Manikin technology, enhancing realism and effectiveness in nursing education. It's a result of the project I am currently undergoing, developing low fidelity mannequins into high fidelity mannequins. So, here are my co-authors, and it's a project we do collaboratively with Lady Nature Hospital. So this is the outline for my project. So the presentation. So it contains introduction, types of mannequins, applications of mannequins in education, advancement, evaluation, future trends, ethical considerations, and conclusion. So without further ado, I am going to the introduction. So mannequins are anatomically accurate simulators that have been used in nursing education since the 19th century. They were initially introduced as anatomical models to aid in the teaching of nursing skills and procedures. Over time, mannequins have evolved and become more sophisticated, incorporating advancements in technology to enhance their realism and function. So, the development of mannequins in nursing education can be traced back to the mid-19th century when anatomical models made from wax or paper were introduced. These models provided the basic representation of the human body and were used to teach basic nursing skills. In mid-20th century, more advanced mannequins were developed, allowing students to practice a wide range of clinical skills such as bandaging and administering injections. As technology progressed, mannequins became more realistic and interactive, incorporating features such as realistic size, physiological and functional. Advancements in mannequin technology have played a significant role in modern day nursing education. So, today they have various types ranging from low fidelity to high fidelity and specialized mannequin as well. So, now mannequins have the ability of simulating complex clinical scenarios, providing students with opportunities to enhance their skills, critical thinking, decision-making abilities in controlled and repeatable environment without any damage for the patients. So the advancements in Manikin technology have greatly improved the effectiveness of Manikin-based simulators and have ensured that Manikin-based education remains aligned with evolving educational and clinical standards. So the purpose of this presentation is to provide a comprehensive overview of mannequins in nursing education, including their types, applications, advancements in technology, evaluation and validation, future trends, ethical considerations, as well as the importance of mannequin technology in nursing education. So now I'm moving to type of mannequins available nowadays. So there are 5 types. First, there are low fidelity mannequins. So basic mannequins or low fidelity mannequins are the most fundamental type of simulators used in nursing education these days. These mannequins are typically made of plastic and have limited analytical features. So they are primarily used in teaching and practicing basic skills such as taking vital signs, performing wound care, or administering injections. Despite their limitations, low fidelity mannequins are cost effective and can be used to introduce students to simulation based learning. So then mid fidelity mannequins between high fidelity and low fidelity. So mid fidelity mannequins represent a step up from basic simulators and offer more realistic learning experience than the low fidelity mannequins. So these mannequins may have more realistic and anatomical features such as realistic airway passages, lung sound, and may also have built-in computer systems and sensors that enable the simulation of specific patient conditions or physiological responses. Mid-fidelity mannequins are suitable for intermediate level learners and are often used for practicing complex simulations such as managing cardiac arrest or other critical situations. So the next type is high fidelity mannequins. High fidelity mannequins are the most advanced type of simulators used in nursing education. These mannequins are closely resemble the human body, including skeletal structures, precise anatomical positioning, and a realistic physiology. Those mannequins can simulate a wide range of programs and physiological responses, interventions, and medications, creating a dynamic and interactive simulation environment. These mannequins are often used for advanced simulations and allow students to develop complex clinical decisions making skills. So the next, specialized mannequins. So they are the mannequins developed for special scenarios such as neonates or cardiac wards like that. So they are used in mostly in Sri Lanka. They are used in neonatal care and gynecology. These specialized mannequins provide learners with the opportunity to develop specialized skills in caring for specific patient populations. They often incorporate unique features and functionalities that mimic the anatomical structure and physiological response of the targeted patient population. So the most recent and the advanced technology used in the world with mannequins is VR patient simulators, which is not available in Sri Lanka at the moment. So the virtual patient simulators are relatively new and rapidly evolving from mannequin-based education. These simulators utilize computer technology and virtual reality to create immersive interactive learning environment. Virtual patient simulators can replicate realistic clinical scenarios, providing learners with the opportunity of practicing clinical decision making, critical thinking and communication skills as I mentioned earlier. These simulators often incorporate 3D graphics, interactive patient histories and dynamic patient response to the interventions as well. So these simulators offer the advantage of flexibility as they can be accessed remotely and provide standardized learning experience for the students regardless of their location. So now I am moving to the design and features of the mannequins. There are several things they need to discuss when designing and featuring a mannequin for the medical education purposes. Mannequins are so first the anatomical accuracy need to be considered. The accurate representation of anatomy is allows clinical practitioners to develop a comprehensive understanding of the spatial relationship between body systems. So then the realistic physiology and functionality. It is important that it includes simulating vital positioning such as heart rate, blood pressure, respiratory rate, and body temperature. So high fidelity mannequins mostly contains these realistic physiology and functionality. The third one is modularity and interchangeable parts. So these design elements enable the educators to adapt the mannequins as well. So the simulated clinical features are important to make sure the environment more realistic as well. So wireless connectivity and remote control, data collection and performance metrics are involved in recent mannequins, and ease of maintenance and durability is used as well. So evaluation and validation mainly consider evaluation of fidelity, which needs to evaluate by the clinical persons whether it's high fidelity or low fidelity. Validation of functionality is also done by the clinical person who is the end user of this mannequins. Educational outcomes and assessments need to be considered because the mannequins is a teaching purpose object, so they have to go through the educational paths as well. So user satisfaction and feedback is necessary to develop more reliable things. So the continued improvements and research is required to develop more user-friendly and advanced mannequins in process. So the future trends and challenges in advancement in technology make day-by-day developments in mannequins. So interdisciplinary collaborations help the mannequins and product developers to do more research and work with mannequins. The standardization and the best practices require that they need to have addressed the quality product and quality training for the medical personalities and clinical practitioners. So with the use of AI, the artificial intelligence has come through to the mannequin technology as well. So that addressing the cost and accessibility is a challenge for the new generation.
We'll give you 30 seconds to just to wind up.
So, in the conclusion, with the review of going through the mannequins used in Sri Lanka and in the worldwide as well. So, mannequins are extremely used in nursing educational enhance clinical skills, critical thinking, and decision making. The challenge is that the high fidelity mannequins are more costly that they can't be afforded by the developing countries such as Sri Lanka and other developing countries. The high fidelity mannequins are accessible to Singapore, Australia and European countries only these days. So the several future trends is to develop low fidelity mannequins into high fidelity mannequins, and this will overcome the gap between the developed countries and developing countries. So So these are my preferences.
Okay, thank you.
I have a question. Now, although you explained about mannequins, I could not see anything about the effectiveness and realism or about the future. So can you tell us what is original about your work?
So this is a review article which
Yeah, no, but in a review, there must be something. So, about the future, or what is special about the developments? I think you were talking about the golden day one and the newer one.
Yes. So in Sri Lanka we don't have any high fidelity mannequins at the moment. Only
Yeah, for the ones, yeah. So tell us, what are the main features that high fidelity mannequins will have compared to the older day ones?
so they have more computer based technologies used to
No,
simulate.
that's not important. What is important is whether it is computer based or not is not what is important. How they will help in the teaching of nurses or nursing students. So explain from that point of view.
So high fidelity mannequins contain more features. So with one mannequin, nurses and clinical practitioners can have more practice than.
Small features doesn't tell us anything. So should be more specific about what those features are.
As an example, low fidelity mannequins doesn't have the iris movement. So high fidelity mannequins contains iris movement and movements inside the eye also.
So what is important about that for the nursing education?
So with the some scenarios, I will.
Those is some. Tell us a specific place where the movement of the iris is important.
Sometimes iris is at normal position and the patient is not responsive, so they can't mimic it in low fidelity mannequins. But using high fidelity mannequins, when they give dizziness and heart rate 50 over 40, then iris also fluctuated with high fidelity mannequins.
Any questions from the audience? Okay. Thank you very much for your presentation. Thank you.
Thank you.
Our third presentation is an overview of techniques of acoustic analysis for the detection of obstructive sleep apnea. So this is authored by KKN Sadara and IMCWB Kohombakadawala. So today's presentation will be by Ms. KKN Sadara. Is a dedicated young researcher in the field of engineering in medicine, currently in her 4th academic year, pursuing a Bachelor of Science degree in Biomedical Engineering at General Research Kolkata Defence University. Her primary area of research focuses on the development of advanced acoustic analysis techniques as a non-invasive early detection system for obstructive sleep apnea, OSA, which is prevalent sleep disorder. Throughout her academic career, Ms. Sadara has been passionate about cutting-edge research in the field of early detection systems. She has extended the scope of her research by investigating non-invasive technologies for prevalent medical conditions, including chronic kidney conditions, where she and her research team received the Unilever Sustainability Award at the STEAM Biomedical Engineering Competition Brainstorm organized by the University of Monash 2022. For her final year research projects, Ms. Sadara is currently advancing her study in the early detection of obstructive sleep apnea. Her A presentation at the research conference will provide an insightful overview of the techniques in acoustic analysis. Over to you. Time will start from now.
Thank you so much for the introduction. Good morning, everyone. I'm Mrs. Sadara, and today I'm going to present an overview of techniques of acoustic analysis for the detection of obstructive sleep apnea. This paper is co-authored by Mr. IMCWB Kohombakadwala, who is a provisional lecturer at the Department of Electrical, Electronic and Telecommunication Engineering at General Surgery University. So this is the content of my presentation. To give a brief introduction to start off, obstructive sleep apnea is a health condition caused by the complete or partial collapse of upper airway, and due to the decrease of oxygen saturation in this condition during sleep, individuals experience some sleep disturbances and also disturbances in breathing. And obstructive sleep apnea condition affects more than 1 billion of population in the world, and in between the age gap 30 to 69. And as you can see in the illustration, obstructive sleep apnea occurs due to relaxation of the upper airway. The problem of my research problem statement is the current diagnostic techniques of obstructive sleep apnea, which would be named as the gold standard method, polysomnography. In this method, a certain individual is subjected to a sleep study for more than 7 hours in a sleep lab, extracting data from more than 7 channels like respiratory rate, EEG and ECG. And in this process, patients find this method more inconvenient and less affordable, and of course its invasiveness, and it causes disruption in sleep. To overcome this problem, researchers investigated alternative diagnosis techniques of obstructive sleep apnea, starting with home sleep apnea testings, which would be portable diagnostic devices which can be worn overnight to detect and measure apneas, causes of breathing, etc. And also, researchers have developed wearable sensors and equipments, telemedicine and remote monitoring equipment, active equipment which would be worn around the wrist to measure the movement, and finally acoustic analysis, which I will be explaining more. And I will be investigating 3 subtopics: snoring analysis, breathing analysis and speech analysis. what is so special about acoustic analysis for the detection of obstructive sleep apnea? It is an early detection system compared to other methodologies, and it is non-invasive, and data-driven insights can be provided, and it has interdisciplinary appeal and the potential for personalized medicine, and also it's an innovative approach. To start off with acoustic analysis approaches, the first one is breathing analysis, and you can see the figure. A person is lying down, representing a sleeping person, and a microphone is placed above him, and his sleeping movements are recorded using a video. And alongside it, polysomnography is also conducted, and you can see that the signals generated are recorded, and through this method, the acoustic properties are diagnosed in breathing, and many artificial intelligence algorithms are based on OSA prediction models like random forest techniques for binary classification, and also IoT connected devices are also built upon these techniques. And some audio features can be extracted using this acoustic analysis of breathing. And the second approach is acoustic analysis of snoring. Well, in obstructive sleep apnea condition, snoring is an easy symptom to diagnose these patients because it is caused by the constricted or obstructed air. So as you can see in the figure, the same experiment have been conducted to capture these snoring signals, just like the breathing. And audio recording from the patients is conducted to snore extraction algorithms, and later it can be classified to identify the OSA related snores or the simple snores. And in this method also, linear discriminant analysis is conducted with nested cross validation. And also smartphone apps are also introduced, analyzing the form and frequencies of the snores, and spectral patterns, the strength and fundamental frequencies of the snore patterns. And in a research paper, I found that how they distinguish this hypopnea unit, which is the partial collection of upper airway. Apnea would be the complete collection, and they have identified how this OSA-related snore can be distinguished from the simple snore. And the final approach would be acoustic analysis of speech. And this is kind of different from above two approaches. In both the approaches, they have used continuous capturing of data from breathing and snoring. And in here, they have used a recording, vocal cord recording, to capture the data. And they have evaluated the voice using acoustic analysis software like PART and MDDP. And they have analyzed techniques, the features like noise to harmony ratio, fundamental frequency, and jitter and shimmer. And by studying the vowel pronunciation characteristics, the researchers have found that there is a relationship between the severity of obstructive sleep apnea and the voice quality. And also they have concluded that there is a vibration irregularity in these obstructive sleep apnea patients, and it relates with the oxygen saturation level. And also they have applied linear support mechanism to classify these algorithms. Not only vowels, they have also used consonant to investigate this method, and the same procedure for data capturing is applied, and it is conducted to a pre-processing techniques, and through linear feature extraction, the classification of the audio signals is conducted, and there they have distinguished whether the person is voicely affected or healthy individual. And the classifications like K-nearest neighbors and support vector mechanisms and fivefold cross-validation procedures are also applied for this technique. To talk about the limitations of acoustic analysis as a detection technique, although it is a pretty easy technique, like it is much applicable than others, there is a limited specificity. While the acoustic analysis can detect abnormal breathing and abnormal snoring patterns, it may not always pinpoint the exact cause of these patterns. And so there can be false positives and negatives, and it can depend on the technology. And there could be some interferences regarding the data collection procedures. And also the researchers have to be concerned about the user compliance. For the future developments, we can apply more advanced signal processing techniques, machine learning algorithms, voice biomarkers and multimodal data along with wearable technology to enhance the existing diagnosis procedures, to make customized analysis for the patients to compatibility with sleep tracking. To conclude my presentation, I would like to point out that acoustic analysis through these three approaches, breathing, snoring and speech, has the potential to be a detection technique of obstructive sleep apnea because it's non-invasive, it's convenient and affordable technique. And researchers have investigated and confirmed this fact through advanced signal processing and machine learning techniques. But it needs to establish therapeutic utility and reliability for this method to be able to use it in healthcare applications. So here are the references I used. Finally, I would like to express my sincere gratitude to my supervisor, Mr. IMCWB Kohombakadawala, and all the lecturers of our medical engineering department for their encouragement and immense support for this project. So, thank you. Sorry, sir.
What authors of the paper?
Sir, myself and Mr. IMCWB Kohombakadwala.
So, can he express gratitude to himself? When you are writing a paper, if you are writing a student paper, your name only is right. But if you are writing a double paper with a supervisor, then you do not acknowledge the supervisor.
Thank you. I will be thinking for.
Right. So, is there only one sleep apnea or are there other types of sleep apnea?
So there are so many types, like there is a type called C-sleep, which means that condition occurs due to conditions straight away occurs due to the brain signaling. Like in this case, it happens because of the collection of the upper airway. In that condition, it occurs due to the signaling process of brain. Like
Okay, so are the responses with your method due to the two different types clearly different?
Sorry, sir.
Now you said there's another type of sleep
Yeah.
apnea. So you are monitoring sound and whatever else. Is the response of the two types different?
No, sir. I only applied this technique for the obstructive sleep apnea.
When you are doing that, for example, if you want to check whether someone has got COVID, you measure temperature and say temperature is high, he has COVID. Obviously, it's not correct because temperature can be high for other reasons. So, can the results of your study come due to other types of apnea or something else?
Yes, sir.
Could it be misleading to the doctor?
Yes, sir. There can be quite mistakes. It depends according to the technology we are using and according to the patient we are using. As an example, you cannot use this for a deaf person. Like his voice production is quite different for a normal patient. There are certain limitations like that, and also you can't use the patient who is suffering from like diseases related to breathing, like that. So there are some limitations in this approach.
Thank you very much for your presentation.
Thank you.
No, I have one question. Actually, is there any relation with this anatomical structure and your banding comparison? Because in ethnicity there may be changes. So, how you overcome that?
So are you asking for the anatomical structure of the throat?
Yeah. With the vocal cord and upper lip.
Yes, sir. Like in some researchers, they have found that obese people tend to have more OSA affected than healthy people. Like the structure of the upper airway collection, like the person has an anatomical structure which can be quite easily relaxed during sleep. Like can be quite relaxed during sleep. That person has high possibility of affecting obstructive sleep apnea than a normal person.
So that means it affects your brain results also.
Yes.
So So then your data set customized, particular customized for one
particular type of patients.
Thank you, Sadara.
Thank you.
The next presentation is a review on thermography and thermal sensors as a breast cancer early diagnostic. The authors MKPSSA Perera, MPA Karunaratne, WPLK Wijesinghe, and NMA Perera. The presentation will be done by Angelo Perera. He is a final year student on BSc in Biomedical Engineering at General Kohombakadawala University, and also he is the chairman of the IEEE Engineering in Medicine and Biology Society Student Branch Chapter at KDU. His research interests are on AI in healthcare, biomedical signal processing, medical image processing, bioinformatics, and medical instrumentation. His final year project is still ongoing on predicting breast cancer abnormalities based on 3D temperature maps of the breast using machine learning. What do you think?
Session Chair Dr. Tharaka Mohotty, thank you for that introduction. Distinguished guests, ladies and gentlemen, I'm here to present a literature review titled Thermography and Thermal Sensors as a Breast Cancer Early Diagnosis Technique, and this is authored by MPA Karunaratne, affiliated from University of Malta and Head of Tech and Strategic Ops at MAS Innovations, WPLK Wijesinghe, Lecturer, Faculty of Engineering, University of General Kohombakadwala University, and Dr. NMA Perera, Senior Consultant Oncological Surgeon at King's Hospital. So I stand before you today to discuss a pressing issue that affects millions of lives worldwide, which is breast cancer. As you all know, breast cancer is a devastating disease with significant global incidence and mortality rates. So early detection is the key to improving the outcomes, and the current breast cancer screening methods, including mammography, ultrasound, and magnetic resonance imaging, have their limitations. So in this paper, I will delve into an exciting and potentially groundbreaking avenue of breast cancer screening, which is thermography and thermal sensors. So let's begin with some sobering statistics. Ladies and gentlemen, breast cancer is now the most prevalent cancer worldwide, which is responsible for approximately 11.7% of all cancer cases. In 2020 alone, there were about 2.3 million new cancer cases, resulting in an estimated 685,000 deaths. Disturbingly, in developing countries, the survival rate hovers at only about 50 to 60%, primarily due to the late stage diagnosis. Even in developed countries with lots of technology, the survivability has dropped up to 24%, mainly because of the late stage diagnosis. Here we can see in gray the statistics for 2020. In black, we can see the statistics for 2040. According to this rate, it's calculated that there will be an increment of 51.9% in the mortality rate per year and 40.8% increment in breast cancer incidence per year in 2040, which is surprisingly very high. The critical importance of early detection cannot be overstated. The survival rate of breast cancer reaches 85% when detected at the first stage, making it clear that timely diagnosis holds immense potential for complete care. It was reported by Karunaratne in November 2020 that 12 breast cancer cases are reported daily in Sri Lanka, which is quite a disturbing quantity. So the aim of the literature review is to identify the availability of a methodology or a device which is FDA approved and that can reliably detect breast cancer with minimal patient complications at the earliest stage possible. So scientific databases such as PubMed, IEEE, Google Scholar were searched using keywords thermosensors, breast cancer, thermography and early detection, and papers from 2010 to 2023 were systematically reviewed here. To address this issue, we must first understand the limitations of current breast cancer screening techniques. Mammography, which is the golden standard, has shown the potential to reduce mortality rates, but it is also seen that it has a few false positives and negatives, as well as radiation exposure to the patient. Breast ultrasound is valuable, especially in cases of dense breast tissues, but breast ultrasound is limited in detecting non-palpable malignant cells. Breast MRI, on the other hand, is highly accurate but very costly and prone to a lot of false positives. When we look at the statistics, the literature says that MRI has the highest sensitivity, which is 94.4%, and mammogram has the highest specificity, which is 75%. So this leads us to the exciting world of thermography. So thermographic techniques capture temperature variations caused by the increased metabolic activity around the tumor cell. So these variations, which disrupts the body's thermal symmetry, can be a promising early indicator for breast cancer. The FDA approval for thermography as a screening technique was given in 1982 as an adjunct to mammography, but it has not yet gained widespread popularity yet, and the accuracy that the oncologists are looking for. When we compare mammography, ultrasound, MRI with thermography, we can see that thermography has no pain at all, and there's no rupture risk, there's no radiation involved, and is very easily accessible with a lower cost and no age restrictions like in mammogram. And especially the breast density is not relevant, and the ability to early diagnosis. So research studies have shown promising results with sensitivity and specificity compared to mammography, but not enough accuracy to be used as a screening method yet. However, thermal imaging alone cannot differentiate between elevated breast temperatures caused by cancer and other conditions. So recent advancements are paving the way for more accurate and accessible breast cancer screening using thermal sensors. So I have found 7 exciting developments in the literature. So among them are the smart bra prototype, which uses magnitude reflection phase and transmission coefficients and is only tested on a phantom. So this has been validated on simulation models and have achieved an accuracy of 83% for a 10 millimeter tumor, but it's surprisingly a very large tumor for early diagnosis. And this has not yet clinically validated. Next we have the IT bra, which is also called as CBM, and has used 16 thermal sensors to develop a predictive model. The model has achieved 78% accuracy, but yet not clinically tested on human trials. An IoT prototype device has been made with 28 bioheat microsensors and has tested on a phantom, and they have achieved to be able to measure breast cancer temperature to a precision of 0.1 degrees Celsius on a phantom, but not yet clinically validated. The EVA prototype has made using 200 thermal sensors was also found in one literature, but there's no specific literature about the EVA alone to be found. Finally, we have a prototype that's made with 16 microwave antennas and tested on a volunteer for over 28 days. But the prototype itself is not comfortable for the patient moving forward, and their results shows that there's a variation in permittivity and less accuracy. So with all these, the conclusions would be that as we explore these innovative approaches, it's very crucial to acknowledge challenges they face. So standardization of thermal imaging values for different individuals is necessary, as breast characteristics can vary widely. Furthermore, many of these technologies have not been validated on a large scale with breast cancer patients, which is essential to ensure their accuracy and effectiveness. Early detection remains the cornerstone of breast cancer control, while mammography is the gold standard. Innovative approaches like thermography and thermal sensors offer promising alternatives that address the limitations of current screening methods. However, they require further research, validations, and refinement to become reliable tools in the fight against breast cancer. Collaboration between researchers, healthcare providers, and policymakers is essential to achieve these goals and improve breast cancer outcomes worldwide. So these are a few major references that have been used, and there's a total of 36 references included in my review paper. And I would like to acknowledge the Faculty of Engineering, especially the lecturers of the Department of Electrical, Electronic, Telecommunication and Biomedical Engineering at KP. Thank you everyone, and I'm up for any questions.
The same comment that I made about the orders go for yourself, but I have more important when we did this, obviously we have talked to doctors who are analyzing breast cancer. For early detection, you said if we detect too late, the survival is 24% around it. With early detection, it can be as high as 85%.
85%.
So early detection is important. What sort of size of cancer is considered early detection?
Less than 5 millimeters.
Less than 5 millimeters. Now, the examples you took, what were the sizes that they were able to detect using thermal process?
In literature, I found that few have used 10 millimeters and 20 millimeters.
Now, are there any which has done studies with 5 millimeter or less?
No, sir, not on the 7 methods that I found.
No, right. So that means at the moment, it is not a suitable method for early detection.
They have not found a method to
Right.
detect a 5 mm unless a smaller lump yet.
Now, again, I don't know much about this type of detection. For how long do you need to wear this special bra for it to be able to detect cancer? Should you do it for a couple of days or can it be just done for a few minutes?
They have not specified that on
I'm not talking about this particular one. In any normal.
Yeah, it depends on the product, sir. It depends from product to product according to how they manufacture it. So, if I'm talking about the product that we are working on for my final year research project, so we are making the product to capture progressive data. So the patient should wear it for a couple of days, months, but the exact time duration has not been decided yet. It need to be.
So it can be a couple of days or months. It's not necessarily a few minutes. If it's a few minutes, even if it's uncomfortable, that is okay. But if you are going to wear it throughout the day, then it can't be uncomfortable.
Yes. Thank you for the questions.
How do you compare the reliability of this, the methods you use and the methods which involves deep learning?
So for the reliability, the main factor is after prototype has been developed, there should be at least 2 to 3 years of clinical trials. And with those clinical trials, and when we compare the results from mammography and our product, we can conclude with the accuracy, specificity and sensitivity of the product. As well as if we are talking about deep learning, the algorithm does matters because when we are developing here based on temperature, there can be temperature increments due to fever, due to different other medical conditions. So all these noises has to be removed from the algorithms as well. So it need to be worn by few patients at least for a couple of years to understand the behavior and give a proper estimate on the reliability of the product. Because now all those 7 devices I found, they have not yet clinically validated. There's only one product that is being worn only on one patient for 16 times. And in the research paper itself, the results section says that they are not very happy with the results they got.
So as per your parametric survey, what is the best recommended method for early detection?
I would say thermal sensors, but we need to have a special mathematical model that can convert this thermal sensor data into a 4D map that can give a proper idea about the internal temperature of a breast. So that is what one of my friends or colleagues is working on, to properly give the temperature profile of the 3D breast, which I'll be using for my machine learning algorithm as well.
Thank you.
Thank you for the questions.
Thank you, Angelo. Thank you.
Thank you.
It's our final presentation for the session. The gesture control loop for a multi-use communication. The authors KD Sehan, RMCP Wijesinghe, and MRA Bandara. The presentation will be done by Mr. KD Sehan. He is a third-year undergraduate of General Surgery, Kohombakadwala Defense University. He is following the BSc in Electronics and Telecommunication, and he is passionate about pursuing his career in the field of telecommunication and electronics. It's over to you, sir.
Sehan. I am Sehan and I want to present you the research paper titled or the digital control cloud for military teams communication. This research paper was supervised by our Major RMCP, a lecturer, Faculty of Engineering and General Sir Dalpatadu Defense University, and Lieutenant Commander MRRA Bandara, a lecturer, Faculty of Engineering, General Sir Dalpatadu Defense University. So let's talk about the introduction. In military operations, effective and secure communication plays a critical role in ensuring mission success. In certain situations, maintaining silence is of utmost importance to avoid detection or compromise. The capacity to remain silent is essential for clandestinely acquiring intelligence and avoiding adversary discovery during reconnaissance missions. And also, maintaining silence during small team operation scenarios such as LRT, known as long range reconnaissance vectors, sniper operations, hostile rescue, and small team ambush missions in flight team build-up areas, also known as FIPUA, helps to keep the covered locations and ensures the element of surprise. The likelihood of a successful operation is increased in hostile rescue scenarios. The action communication through silence enables the respect to coordinate the actions without relying on the captors. So, the importance of effective quiet communication cannot be emphasized. Using traditional communication methods in given nature of these operations, which is not soldiers working in tiny groups need to communicate. For the mission to be safe and successful, as well as to retain sleep, it is essential to be able to communicate orders, directives, and situational information without using mobile tools as well. So, using of available communication equipment and passing verbal messages indetectable in enemy territory. Therefore, as a result, military hand signals are being used as a traditional signal method to pass information and orders securely. Regular listening terrains like dense jungle, urban build-up areas, hand signals is not effective since soldiers are not visible to each other. So we are looking into the available military communication equipments. So we can see three categories of equipments that are used in military. For general military operation, Kaugar, Motorola, Harris, etc. radio communication equipments are being used. It provides communications in noisy signals. It does, however, rely on voice commands just like conventional radio systems. And also, gesture control blocks using flex sensors are not available as a product of relation or research application. So now let's talk about the flex sensor integrated general applications. So as you can see here, hand gestures are used in sign language and a way of communication for different people as well. So you can take a clear idea when considering those diagrams and pictures. Not only that, but also the flex sensors glove is able to control video games smoothly. Nowadays, worldwide, the video games are going far. So those are conducted and manipulated with those flex sensors. And also in healthcare, the flex sensor gloves are being used to conduct operations. So the doctors can conduct operations without paging the patients and take the measurements. So our product uses hand gesture gloves for silent communication, make use of cutting edge sensor technology and gesture recognition algorithms. These gloves come in sensors, primarily flex sensors, which record the precise movement and hand locations of the user as well. So by doing away with necessity for directives that could be heard without jeopardizing operational security, this enables soldiers to remain cover tactical instructions like movement signals, target designations, or squad formations can be communicated by silent activities. So basically this is scoped into internal use. Hand gesture gloves made for silent communication provide a useful way of military personnel to communicate orders and information provided. And and also boosting situational awareness and operational safety as well. So as technology advances, these clouds have the potential to become a vital component of modern media communication systems, providing soldiers with a silent and efficient means of coordination and maintaining the practical edge in complex and sensitive environments. So now let's talk about the methodology we use in this product. So the system block diagram is here. First, while using hand movements in the transmitter, the bending angles of the flex sensor are measured. So this is the initial point of my project. Then the program is done on Arduino Nano board with command being sent for each bending angle. So the bending angles are assigned for a command that we are assigned for these military operations, and that can be customized as well. The orders are then modified in response to the bending angles recorded by the flex sensors, and the push button is used to guarantee that the delivery of the result signal to the Arduino board. When we are talking about the power, a 9-volt backline battery powers the Arduino board with around 550 milliamperes of energy. The hands-free gadget and the flex sensors are powered by the Arduino board as well. For an example, one main transmit Bravo don't crash over, which is associated with a 45 degree bend in the first finger. So, as an example, the hands-free which is attached to the receiving end will receive the voice output as Bravo don't crash over, which is previously command that we have used in the project. So, only one flex sensor is used in research work. However, the quantity of flex sensors can be chosen according to the nature of the assigned mission that we are using in the military. As regulated, the transmitter end can produce the following speech commands if 5 flex sensors are used on each finger of the gloves. If the receiver end can hear the same command through the link. For an example, when the flex sensor 3 is activated, we can get the output as zone as tabulated in the diagram. So let's talk about the components here. Mainly we have used Arduino Nano module for the command design and the power inputs. So the microcontroller used in here is Apnea filter weight, and the power consumption is 90 milliamperes, and also the operating voltage is barely 5 volts. So this is a transceiver module we have used here. It's a class A transceiver called Bluetooth module onboard antenna LM400. So this is operating at the frequency of 2.5 GHz frequency band, and also this has an IC antenna. The transceiver output of this transceiver module has a 18 decibel millivolts and is the maximum value, and also the receiving sensitivity of this module is minus 88 decibel millivolts, and it's a typical value. So the main components we use in this project is the flex sensor. We have used the flex sensor 2.2 inches and the flex sensor is flexed the resistor across the sensor increases. The flex sensor has an angular sensitivity from 0 to 180. Decrease considered to the finger bending. We can adapt to 3 angles for one flex sensor according to our purpose. Patent technology is by simple. They claim these sensors were used in the original high-tempo power. So this is the final product in the components. As you can see, there is the hand-free flex sensor, Arduino Nano, and the Bluetooth module, and the 9-volt battery as well. So this is the final product, that is wearable handheld setup. So when we are considering of the results and discussions, this product has been tested in 3 different outdoor environments and measured the received power levels by increasing the distance from 10 meters by an increment of 10 meters of sender and receiver up to 100 meters. So there are 3 scenarios here. The scenario 1 is angle. Actually it is located at the binocular area. So there are latitudes and longitude directives as well. And the scenario 2 is urban environment. We get the location in a faculty building areas. And also scenario 3 is open environment. It is located at the KDU rugby ground. So when we are talking about scenario 1, the resistance. Up to 15 meters range, acceptable power sources are received with clear voice outputs and power levels were not detected after a range of 50 meters and no voice output were received. In scenario 2, up to 60 meter range, acceptable power levels were received with clear voice outputs. Power level was not detected after a range of 60 and no voice output were received. In scenario 3, up to 7 meters range, acceptable power levels were received with clear output voice and power levels were not detected after a range of 70 meters and no output voice were received as well. So this is the results and discussions. In the left hand side, we have the field test results. On the right hand side, we got the received system power versus range. All the measurements were taken by a communication analyzer. So we can see there are no signal received after the 70 meters range. In the conclusion and the future works, this technology transforms how communication is done, especially military operations and the protection of the troops. Soldiers must integrate hostile training small, such as for equipment for a variety of operations, including reconnaissance, LRP, sniper operations, hostage rescue, small team ambush missions, fighting, build up areas, by allowing soldiers to convey orders and information through hand gestures while maintaining the silent communication. With the gesture control block, soldiers can effortlessly communicate crucial messages without seeing a single word. The consistent and simple means of communicating commands is supported by the ground, ensuring clear and efficient communication. So, the gesture control block can also be a powerful tool in challenging operational environments. It improves situational awareness, speed of decision making, and raises the success rate of a mission of all as well. And also, the gesture control block's capabilities can be increased, and it is able to recognize gestures and improve by adding more flexes. A wider range of commands and activities are possible thanks to the finer control and accurate gesture detection made possible. The ground becomes more versatile and adaptable to various user performance by recording a wider range of time. Using an external antenna, the Bluetooth module, the operational range of the address can be extended up to 100 meters in the open area. So, thank you for the attention.
Can you move that? Please, right. We have
Yes.
So, can you explain using this? In the right cover. Can you explain using this tag what exactly the signals you are going to send and how they are being sent to the camera? Because she said you do a study to the camera. So, what type of signals are sent?
It's actually voice commands.
Yes, no, but it's not the voice that is going. It's
Micro signals. It's the micro signals.
Alright. So, does it go through trees?
Yeah, in the wooden areas, up to 16 areas, they can be acceptable with.
So, that need not to capture between the trees?
Yeah.
With a normal jungle?
Yeah, this one, the wooden areas.
Right. With your hand, can you just show me what? Now we had a list. Can you show me with your hand how you would actually do that? Now using your own hand, show me a gesture that you will use.
Just take this finger.
Okay.
So, if we assign the command Bravo task over, with the 45 degree of this side, with the flexes is attached to the finger. When I bend this finger to 45 degrees, then the signal is received. So basically, it is used in the building areas. We using the commands.
Is how many? Now at the moment you have something like 5 commands that are sending.
Yeah.
How many commands can be done using different combinations?
Different possibilities. up to 10 to 15 commands can be 10 to 15 commands can be designed, but the accuracy is getting low with the command is high.
No, why can't you go to, let's say, 25 or 50? What is the limitation in sending more commands?
The limitation is you can't use the five fingers to the whole hands. So the accuracy is getting low with the bidding enter is getting high.
Now, if you are converting whatever you are doing with your fingers to a microwave center, then why can't you send other information? Why limit to 5? These are pre-scheduled parts. No,
they know.
I know. So, if there are some emergencies, is there no way of giving new information?
No, we can assign more commands. In the military teams, this is made up to internal teams. Not to communicate, but there is communication. In the internal military teams, so we can use more commands. Using diagrams, we have used only 5 in here, but we can use and generate more commands with more flexibility.
Considering the type of commands that you are planning, so accuracy of issuing the command is most important. Otherwise, miscommunication can lead to a complete chaos. So then, how do you exactly make sure? So, what are the constraints? So, let's say that does it mean that all other fingers are at some location while the single finger is moving? Because sometimes it may be difficult to bend one finger without other fingers also trying to respond parallelly. So, as far as how will you ensure the discrimination of these actions in a situation like this?
So we can consider 5 fingers. We can use 5 different commands using the bending fingers. So if I take 45 degrees, do this.
No, I understand. I'm asking how to ensure the discrimination. So when I try to bend the third finger, sometimes by mistake some other fingers may also bend along with it.
No, sir. This product has a push button. When we hit the push button, that only the signal system.
That important piece was not present. So that's to have it. And other things that when the receiving persons are keeping earphone on or headphone on, won't it expose the person not getting any sound from the background? Won't it be a disadvantage?
No, sir. Actually, this is according to the military, sir. So the training is must be given. So I don't think that.
No, I mean the person might lose getting the sounds from the background. It might have important feedbacks.
No, that will not interfere in the background sounds.
So keeping the ear free would be better. You might have some other location to get diseases when it was by communication. You can let it be heard, but keep the ear free would be. I just got it.
I agree with Karunarathne. Now, the important part is the hand gestures. So why do you want to send it as a voice signal? Why there's a phone, I must say phone. You can, so can't it also be sent to some other device at the day rather than voice?
So actually, in this scope is to the silent communication, and the visibility is a main factor. So when we getting voice commands, actually it can be heard by the receiver. When we put in the hand to the receiver.
I think what I was saying, if the receiver is also inside the jungle somewhere, you would not want to wear earphones because it will block the sounds coming outside.
No, sir. When games, we always wear the hand free.
So
So that is the normal. So you can explain. Yeah.
Sehan, now I heard that how many gestures you can transfer with the system as you done the research?
To
That 15.
to the
So we have few concerns when the soldier is a battle, especially in the special operation. We are discussing about the special operation. He may restrict to the 15 messages. Gestures, like if you should answer the only 15 messages, the limitations are because when you are in a special scenario, it will be restricted to the messages. My main concern is normally in the battle, maybe when you go for a 4-man and there is only one officer. The soldiers are like their education level is low. So how can you remember this is the message, and when you have bend this finger to this level, how can he keep that mind, that thing, his mind, because it's a very difficult thing when you're in a battle and thinking on operation. You have to clearly bend the exact finger. So that if you wrongly bend another one, you are sending a different messages to the other. So he's keeping that mind, the 15 gestures, they're not easy when you're in a battle because you have a lot of people thinking around. So can you explain that how you manage that in research?
It's actually we have marketed into the military training. So if the command is hitting high, the accuracy is hitting low.
I'm not talking about an officer or a if a soldier is in that scenario, his capacity of keeping us. So that's why my question is.
So for that, I will answer for that. Sir. For this one, for like other devices, we have a manual for that. Sir. Basically, he can use that manual and look at the building and angle and bend while pushing the push button. Sir. So I think there will not be any doubt for that. So you know that he can do that. But in this case, actually, we have restricted the number of command to 5. So, as per our requirement, we can expand that also. But however, initially now we have focused on one sensor. But we will, in the future, we will see how we can develop this approach.
Well, that means the soldier in the battle have to refer to the manual when you want to send a message. Yeah, that's the thing. Like he's in a very special mission. Is referring a manual in battle in a very hard terrain, and it's not a practical thing for me because when we look at for the actual scenarios. That is thinking is okay. As thinking and the research is I'm not doing, but the application is I'm not happy with the application because it's not especially when you thinking on LRRP operation. Before the LRRP operation, the person was going for operation, going for 2 weeks special what's called therapy, and after returning they are go for and one month special therapy because of this mission. So when they are going on that mission, I don't think that they have a certain time for thinking or referring manuals. They have very less time for when it is a special operations.
So with that, I agree with your comment. So this is a predefined commands and directives. So when we are doing mission planning and the mission briefing, so they are briefed to pass the message, and they should train, as you said, during the previous training, as you said, they should brief and they should train to pass the messages, because this is why we can use the same thing when using a communication set also, but we need the quiet communication and the secure communications to pass the messages in between the team. So that's why we propose this kind of methods.
My advice is it's better if you are using flexible substrates, making anything your hands are very restricted, so you have to have the weapon, you have to take some, say sometimes mines, so that time you will be restricted, so better, so you should have a thing, or you can have a thing like touchpad, so you have more options, you have more buttons, something like that, so it work out, because rather going for the fingers, because when you are firing, your finger is bending more than 45 degrees.
No sir, for that concern, already this is not working sir. Only we press button, that means push to toes, and then as general
normal sensation. Basic main thing is that thinking of a soldier.
Okay, thank you. Thank you very much. Now it's come to the conclusion of the session. The session is actually achieving resilience through advances in biomedical and telecommunication engineering. This particular field is, for me, is actually very valuable because it possesses few disciplines, knowledge and skills of physiology, biology, healthcare, health information, mechanics and engineering. I think all the presenters who present their papers try to do their knowledge and skills to keep this session alive. And with this expert comments, I think in a day you will be able to do more on the and find some issues, find the solutions for the issues in the healthcare, world healthcare industry. And also I think we may not be disheartened by the comments because the idea and the thoughts are the most valuable, because what we think today may be not the realistic thing in the future. So the idea, for me as the chair, I believe the idea is more important. So when it's come to the sports in 1968, the fourth speed in Summer Olympics, he is the first person to have the head first in the high jump, and he was disqualified. But his idea now bring world records. So I believe, so whatever the thoughts we from the chair and the panels and the experts may be not valid in the future. So I think, but they have given a good eye-opening for you all. But they are that you may have not thought done in the presentation and the research. So take all these things, facts, to your future, and I hope one day you will become the renowned biomedical engineers and the technicians or the telecommunication engineers in the future. So I would like to thank all of you, and I would like to thank the panel of judges for keeping this session alive. Thank you, the gentlemen who attended this session, and I hereby conclude the session. Thank you very much.
Tharaka and all the authors for your valuable contribution to the research community. Now, I would like to invite our session chair, Dr. Tharaka, accompanied by the head of the Department of Electrical, Electronic and Telecommunication Engineering, Captain Wijesinghe, to award the certificates to the authors who presented. Miss BHMD Wijesinghe. Mr. MKPSSA Perera, Mr. K.T. Sehan. Thank you very much, everyone. Dr. Tharaka and Captain Hewadikaram, I would like to kindly request you to remain there for a moment. So now I would like to invite the Dean, Faculty of Engineering, Professor Karunarathne, to present the certificate and token of appreciation to our session chair today, Dr. Tharaka Mohotty. So the session today was evaluated by a distinguished panel of judges, and now it's time to appreciate their service as well. So I would like to invite again the Dean, Faculty of Engineering, Professor Hewadikaram, to present the tokens of appreciation and certificates for our judge panel. Senior Professor J.R. Lucas, Professor J.P. Karunaratne, Dr. W.P. Prasad. Thank you very much, sir. So in the meantime, I would like to kindly request the panel of judges to continue the evaluation in the post session as well. And now it's time to present the award for the best paper of the session. So I would like to invite Senior Professor J.R. Lucas to present this award. So the award for the best paper of the technical session 2 of Faculty of Engineering at the KDU IRC of 2023 goes to Gesture Control Glove for Military Trainings Communication by Mr. K.T. Sehan and Mr. Wijesinghe. Thank you very much. So this marks the end of the technical session 2. I would like to invite all the distinguished guests to join us for the lunch which is arranged at the cafeteria. And in the meantime, I would like to also encourage all the authors to publish your research work in the Journal of Advances schedule. Thank you very much, ladies and